First of all, thanks to the organizers for the invitation and for putting together a very interesting session. Conference. We'll see about the session. This is a joint work with Jeff Allen, and the problem with starting with a very ambitious title is that, of course, you're bound to disappoint with how you do the paper. So this started out with more of a theoretical curiosity, and just to be clear, this is going to be something that I'll think about as a macroeconomist, the idea being we want to understand how inequality affects welfare through very specific behavioral patterns, in particular through health investment in this model. Now, the traditional way economists think about inequality is to ask, to what extent does inequality affect our opportunity set? There is increasing work, partly motivated by experimental evidence, that people seem to demonstrate inequality aversion or they care about fairness. And these things should be therefore part of how you think about human welfare, how you think about the consequences of inequality and policy in general. So that is the question I want to start out with. How does inequality affect welfare when people are aspirational and they directly care about their relative status? So in the model that I'm going to propose, I'm going to be a bit of a macroeconomist in the sense I'm going to stick close to literature that has come before me. And in that literature, people will have desire for a certain aspiration level. And that aspirational level is what's going to introduce into the model a relationship between inequality and human behavior. It turns out that the way I'm going to introduce aspirations will make it fairly tractable very quickly, so I will have to rely on quantitative techniques. So I will construct a life cycle model. I put life cycle within quotes for reasons that will be obvious in a few minutes. I'm going to allow people to engage in health production. And the idea is going to be the following. It is going to turn out to be the case that when you exogenously increase inequality in a way that I'm going to be very precise about down the road, it motivates people to do things that makes their economic lives better. So people are actually better off economically when they're aspirational and when inequality increases. But it comes at a cost, and the cost is going to be in the form of loss of health production. And I'm going to use that model to tell a story about that's consistent with something that has also been written about a lot in literatures outside economics, but some in economics, which is on the relative income gradient and the effect of relative income in particular on health. So let me start with the second point. Unlike economists who have focused a lot on the effect of absolute income on health production, sociologists seem to take it as a matter of faith that relative income status has a big impact on health outcomes. And the health outcome, by the way, in the model is going to be purely survival or mortality, because that's what is easiest to calibrate to in the data, and it's also what some of the empirical studies focus on predominantly. So this idea about inequality having a direct effect on health production through relative status is probably most widely associated with a British social epidemiologist by the name of Richard Wilkinson, who in a series of papers and books has advanced the idea that inequality has a direct effect on people's behavior on health production, that inequality is in of itself a health hazard. Now, when Wilkinson is proposing this hypothesis, he's thinking largely of post-epidemiological transition countries where absolute income, in his view, has less of an impact on health production. I'm going to actually not have time to show that in the paper, in the presentation today, but in a quantitative life cycle model, it's very hard to get absolute income not to matter. So in the story I'm going to tell, absolute income always plays an important role. In fact, absolute income plays the predominant role, but relative income also is going to play an important channel, is going to introduce an important channel that affects human welfare across the distribution. So Wilkinson's data is not the kind of data that we economists would really jump up at. So there's largely based on cross-country correlations. So for example, he starts out by saying that there is no discernible relationship between life expectancy at birth and GDP per capita across the OECD countries. But if you then look at life expectancy at birth and inequality measures like the Gini coefficient or income share of the lowest 40%, there's a very strong negative relationship. So more unequal societies tend to have realized lower life expectancy. And similar stories you can tell in terms of changes. Income gains by the bottom 40% are strongly associated with gains in life expectancy at birth. Now, those studies are then used to tell a causal story. And the motivation to tell a causal story comes from some relatively more micro-level studies. So, for example, David Marmot's work on the British Whitehall studies finds that across the British civil service, there's large differences in mortality outcomes. So, for example, at the lowest hierarchy, mortality rates are 3 times more than at the top hierarchy. And then he finds that about a third of that gap can be explained by the effect of absolute income. Presumably, the remaining part is by other factors, including relative income. And then it's biologists who have actually really advanced this hypothesis, arguing, for example, that human life expectancy is maximized the closest we are to our hunter-gatherer origins, where people were relatively homogeneous in terms of their abilities. We were very active. Of course, we had diets that were quote-unquote healthy, but more fundamentally, there was not strong inequality. And any deviations from that, in particular in terms of social hierarchy, tends to introduce stress, tends to introduce the idea that people have a natural tendency to dominate others, and that dominance triggers in them biochemical responses that elevate their health hazard permanently. The most famous of these studies actually comes from biologist Robert Sapolsky, who conducts a series of these studies in Africa on baboons and trying to understand the social hierarchy, how it's imposed in these groups of baboons. And based on that, he argues that baboons who are very strongly dominated, for a while they show marked improvement in terms of how they deal with it through release of things like cortisone. But over time, they get inured and their cortisone level permanently rises, and that causes them to die prematurely. Now, it's a big leap going from baboons to humans, but the idea, once again, is that these are indicative of the kind of biochemical responses that can be associated with the effect of inequality in health. Just to be clear, I have nothing to say about these automated biochemical responses. That's not something that I can formalize in an interesting way as an economist. So what I'll focus on is the other side, which is what are the behavioral channels through which inequality can actually have an impact. Now, just as Wilkinson's work gained a lot of traction, people also started to critique it. One simple critique is that just because you observe a negative correlation between life expectancy and inequality doesn't mean it's a causal relationship. You can tell a very simple story. Suppose the health production function is concave in income, and by Jensen's inequality, you do a mean preserving spread, automatically you're going to reduce life expectancy. So that's a story of an association. And yet, if that story is true, what we should also observe is that the correlation would be very strongly negative across a large set of countries. And that's not what we observe. So the other line of criticism that people have taken, including us in this paper, and Deaton in particular, is that this aggregate evidence is not at all robust. And we actually uncover some evidence that, depending on how you slice the data, for example, we look at 1990 through 2010, we see that every 5 years, that correlation has been steadily weakening. And we try to make sense of that in terms of a theoretical model. At the same time as this is going on, some people have looked a little bit more carefully at the disaggregated evidence. 2 people in particular, Deaton, or 2 sets of authors. Deaton has a series of papers on this, and Eibner and Evans have a very well-regarded paper on this. And then following them, some social epidemiologists have picked up. So there are 2 papers I've cited down there that look at Japan and Norway. So, for example, Deaton starts out with Itzaki's index of relative deprivation. So on the equation I have is a very simple parsimonious specification where m of x is some sort of a health outcome. In his paper, it's a mortality outcome at an income level x. And he's positing that that mortality rate has, so a relative deprivation, the second term on the right-hand side, which is measuring average income shortfall between you and everybody who's above you in the income distribution, suitably deflated by mu, the average income of everybody else, everybody above the distribution, the conditional mean. That coefficient B is positive. Now, Deaton implements a version of this with the effect of absolute income controlled for, and he finds that relative deprivation across the US states is a very strong negative impact, positive impact on mortality outcomes. Eibner Evans kind of take this a little bit further and look at a whole index of health indicators, including self-reported health, mortality, and they find especially the strongest evidence is for smoking and coronary heart disease, things that are widely associated with stress-related behavior and excessive work conditions. They also look at broader measures of relative deprivation. So here's what I'm going to do. I will try to construct a theoretical model which gets at this idea that relative deprivation of some form has an impact on people's behavior. And the way I'm going to model it is by thinking about people being aspirational. And also, to be clear, when I say aspirational, some of you in the audience may have heard of literature on status seeking or keeping up with the Joneses. So I'm going to have a little bit more of an elaborate version of that status seeking or keeping up with the Joneses. I'm going to call it aspiration because just to kind of fix a little bit the idea that it's broader than just kind of trying to aspire to a certain living standard. So let me start out with the health side first. So this is going to be a model that is in the spirit of Blanchard and Yari's perpetual youth model, where the survival rate is endogenous, and the endogeneity of the survival rate is going to be modeled after Grossman's work on health production. So individual I's health capital evolves according to that equation up there, standard formalization. The last term on the right-hand side is investment in health. Investment in health is a composite of healthy time that is invested. That's the first term, 1 minus Li. And goods, health goods that are invested. You can think of health goods as simple as going to clinics, visiting doctors, having a healthier diet, nutritional supplements, if you believe they affect health outcomes, and so on and so forth. In the Grossman model, the way it works is that people have a unit time endowment. They decide to allocate that time endowment between labor supply, leisure, and then healthy time investment. I'm not going to make a distinction between time that is consumed as leisure and time that is invested in health production. Part of the reason is because the central trade-off in the model is not going to depend on that, so I want to be a little bit parsimonious. But partly it's also because when I want to go to quantify, I don't have a lot of information on how much people invest in healthy time investment in health production. I mean, you can argue, for example, the vacation I take from a very stressful job is pure leisure consumption, but it's also something that goes into health production. It replenishes my health stock. So when you come up with examples like that, it's not clear where you should categorize that time, the time that you don't supply to the labor market. Phi I is the survival rate, which is going to be an increasing concave function of the individual's intrinsic health capital, and I'm going to use the uppercase phi to denote conditional survival rate, that is the probability of surviving at age t, given that you've survived in the previous periods. The preference side is going to be a Blanchard-Yari version. The distinction being in the Blanchard model. So the Yari model has exogenous survival rates, but that's age-specific. The Blanchard version is everybody faces the constant probability of death or survival. And in my version, the probability of survival changes over the life cycle depending on how much health investment people make. So they will be maximizing expected lifetime utility, which is going to be coming from UIT is the utility payoff from being alive, and U lower bar is the utility from being dead. In my model, because of the way I calibrate it, utility from being alive is always going to be negative, so I'm going to set that U lower bar to be sufficiently negative so that people always prefer to be alive. So suicide's not allowed. Now, people are going to maximize this lifetime utility subject to usual budget constraint. The flow constraint is they allocate their income. Income comes from labor income. Individual I has labor productivity theta I that's stuck with him or her for the entire life cycle. And LIT is the number of hours of work that's supplied. R tilde I is the annuitized return on assets, which are A. And of course, people allocate this between consumption, between new assets, and investment or spending on the health good. All right. So the felicity is going to be a composite of consumption that the individual enjoys. And the marginal utility of the consumption is going to be shaped by the aspirational level of consumption, C bar. And that C bar is going to be idiosyncratic, that it's going to be specific to the individual, and I'm going to formalize that in a minute. And then the last term is the standard preference over leisure. Now, the macro literature, so the specification, by the way, follows a lot of the macro literature, starting out with Abel and Galee's work, trying to think about common aspirations level and using that to explain things like asset price dynamics or the equity premium puzzle. To also, in fact, some of the work has been done by David here, trying to understand the effect of aspirations that are formed on the basis of your parents' living standards and its impact on your behavior. So the macro side typically tries to model this as a consumption-based aspiration level. The way I'm going to think about this is though very similar to what Deaton implements in terms of relative deprivation, except rather than income, I'm going to think in terms of relative consumption deprivation. So what is C bar? C bar is the average consumption level of everybody who is above you in the consumption distribution. So people have upward-looking aspirations. They don't care about those who they have left behind. They only care about those who are above. And everybody in the income distribution behaves in the same way. The only difference is that depending on where you are in the income distribution, your aspiration level are going to be different. Before I will have a little bit more to say about that. Before I go on, there is going to be a restriction that I put in. So notice that there's a psi parameter on the C bar in the utility function. I'm going to actually play around with that psi because that is going to dictate responsiveness to relative status. Now, the psi has a natural upper bound. And the upper bound comes from the fact that you can rewrite the utility function and ask, of the last unit that's spent to increase utility, how much of the increase in utility is because of relative status? And because that number cannot be bigger than 1, that naturally puts a bound on psi that is, actually it's a bound on psi times that on between 0 and 1. Because in the benchmark model, I'm going to set the psi to be exactly sigma minus 1 divided by sigma. I'm actually following some of the macro literature there too. What will turn out to be the case that in the benchmark case, the baseline case, the individual's utility will depend only on his consumption relative to the mean consumption, the aspirational consumption of those who are above him. Okay? All right. The model gets complicated fairly quickly because the consumption distribution is endogenous, and it's in Ramsey model, people being born and dying. So there's a lot of dynamics that's going on in the background. So let me try to get a little bit of glimpse into how this relative consumption deprivation changes along the distribution. Suppose the consumption distribution were continuous and it was exogenous. And suppose the consumption distribution was log normal. So that's the chart on the left. What that shows is that as you move from the poorest individual to the richest individual in that particular society, richest in terms of consumption level, the aspiration gap initially precipitously declines and then gradually declines. So the aspirations gap, in other words, aspirations gap being defined as your aspirational consumption relative to yours, is the highest for the poorest, lowest for the richest, even though the rich are also responding to aspirations. The different curves are showing that as you increase the Gini coefficient, inequality, you can do the same thing with Theil index or Kuznets ratio, for example, that as the inequality index measure of the distribution goes up, then average deprivation across the income distribution goes up. So everybody is more deprived, and therefore they're going to respond more strongly when inequality goes up. The right-hand side is a Pareto distribution. Because of the fractal nature of the Pareto distribution, the aspiration gap doesn't change along the income distribution, or consumption distribution. In our model, ability is going to follow Pareto, but that's going to induce an equilibrium consumption distribution that looks more like the log normal case. So that's something to think about, because those are going to drive the results primarily. All right. So the survival function is something that we're going to calibrate to, and what we're going to do is we are going to play around with that psi and the tau to match. So the model is calibrated to the US in 2000. We're going to pretend that the US economy is in steady state of this model. I didn't write down all of that dynamic programming. All of that is taken as given. What I'll do is to say that in this model, the only way I can answer questions at this point is by focusing on steady states. And one of the reasons is that the entire distribution of consumption becomes a state variable in the individual's decision problem, which I do not know of existing, even though kind of these computational techniques have come far, it's still not equipped to handle all of this and handle general equilibrium prices. So I'm going to do actually something very simple. I'm going to focus on the steady state part, and I'm also going to shut down general equilibrium price effects. And I'm going to talk about that if I have time, but that might not be the case. So people differ in terms of the productivity that they're born with, theta I, the initial assets, the human capital, the health capital. When people die, they're replaced by somebody who's completely different. That person will have his own theta I productivity draw and will have its own assets and own health capital. Because of an annuities markets, I'm going to assume that people are born with zero wealth. That's consistent with saying that there's a mutual fund that takes away the assets of everybody. So everybody is born without any assets, which means in the long run, any heterogeneity in the asset distribution is entirely because of heterogeneity in the labor endowment and labor supply. So even though I'm going to shut down general equilibrium effects and dynamic effects, there will be equilibrium effects, because what is required in equilibrium is for people's aspirations to be consistent with equilibrium consumption. So given the consumption distribution, they form forecast of what their aspirations are. That induces consumption behavior and a consumption distribution that better be the consumption distribution they started out with. So that's the way the model is going to be implemented. So I figured the best way to understand what's going on is to show you a series of pictures. So let me first focus on household level behavior. So the thing I'm going to focus on here is the policy function or the optimal behavior in terms of health production, which means healthy time that's invested or its complement labor supply or the health good that's purchased. And then the third picture is looking at the effect of those two in terms of health production. So in the first two charts, there are three lines corresponding to different productivity levels. Black is the lowest productivity, and the blue one is the highest productivity. So what you see is, and the way this is produced is by exogenously varying the aspirations level and asking what is the effect of the aspirations gap on different kinds of health behavior, including labor supply. So people at the lowest tail of the distribution, so people who have very little aspirations gap, that is the rich in terms of the model, they do not have much of an incentive to supply labor because partly they are motivated by how well they're doing relative to everybody else. If they're the richest guy, they don't care as much in terms of improving the living standards. So the marginal utility of consumption is not as increasing in the health status, in the consumption state, relative status. So as you increase the aspirations gap, labor supply increases. And that means the complement of that is that healthy time that's invested in health production precipitously declines. A similar kind of story happens with health spending. Notice that in equilibrium, what will happen is the poor guy will be at the further end of the black line, and the richer guy will be at the lower end of the blue line. So equilibrium effects will be magnified more than what this is implying. Now, the outcome of that is that health production suffers tremendously. So the red line down here is showing how much over time health production suffers because of differences in health investment and as health goods investment as the aspirations gap is exogenously changed. Just to be clear, I want to also understand if this effect is being driven by the effect of absolute income or absolute consumption levels. So what I do in the third picture is shut down the aspirations channel by setting that psi responsiveness to 0. And what it shows is that independently of the relative status has no effect on health production. It's a slight negative number because this individual has been endowed with a health capital slightly above his steady state level. But the important thing is that there's no discernible effect of relative status on health production. And in partial equilibrium, what this implies is that aspirations is going to magnify differences in survival across the distribution. So, for example, if you look at the lowest productive individual and ask, well, how much does his health production suffer because he's aspirational, that turns out to be a gap of about 2 years. So there's a shortfall of health life expectancy of 2 years. Across the distribution, if you compare an aspirational society with a non-aspirational society, the aspirational society has a life expectancy gap of about 5 years between the upper and lower deciles, and in a non-aspirational society, the gap is about 2.5. So a sizable difference that's coming from partial equilibrium. Okay, then I do a series of experiments in the model. So the first one I do is something that's motivated by very early work that I'm surprised that has not been actually formalized in economics, so people have not tried to think about it a little bit. So Friedman has this argument in Capitalism and Freedom, and it's an argument that Okun also picks up on in Equity and Efficiency. It's an argument that you hear a lot among right-wing politicians and economists, that inequality has a big positive effect because inequality motivates people who are not doing as well to do better. And it seems this model is a very simple, clean model to test that prediction. So are our economic lives better off because we're aspirational? The short answer is yes. So what I do here is, again, turn off and on the aspirations parameter. So when people are not responding to social aspirations, which is the red line, that is looking at total income, so sum of labor income and asset income across the distribution, across the productivity distribution, because that's the exogenous variation in inequality that I can introduce to the model. And the black line is plotting the best fitting line of income outcomes if those same productivity households are suddenly made more aspirational. So across the income distribution, what happens is aspirations motivates people to accumulate more assets, right? They are more responsive to consumption. They can increase their relative status by either increasing current consumption, and they do that by increasing labor supply, or they can increase their consumption in the future. One of the ways they can do that is also by increasing labor supply and diverting part of that increase in income towards higher asset accumulation. So both asset accumulation and labor supply increases, and so people are better off. What's less clear is that actually there's a differential effect across the distribution. So what we then do is that, well, let's think about what the equilibrium inequality in income and consumption are between aspirational and non-aspirational societies. So let's just focus on the second one, because consumption inequality is the more obvious measure to think about in this model. So on the horizontal axis, what I have is different simulations of the model with different underlying Gini coefficient for the theta, the productivity distribution, and I'm looking at the implied inequality of the consumption distribution. On the vertical axis, corresponding to those same productivity distributions, I have turned on the aspirations parameter, and I'm asking in equilibrium how much consumption inequality am I observing. What you observe here is that the aspirational society almost always, actually, not almost, in this particular case, always turns out to have much higher inequality, significantly higher, I would say, compared to the non-aspirational society. So it must be, therefore, that people at the lower tail of the productivity distribution are not allowed to respond in the same way or proportionately as people at the upper tail of the distribution. Now, if you think about it, this is a complete markets model. So there are no credit frictions. So there's nothing that's preventing the poor from saving as much as the rich. In fact, the poor have a bigger aspirations shortfall, so they should respond more strongly. It turns out that the answer is that labor resources are fixed. So the poor, because they have a higher aspirations shortfall, they're already overextended on the labor market. They're supplying a lot of labor. The health investment is suffering a lot. When you then increase inequality in these societies, they can increase their health investment or increase the labor supply only so much. The poor or the middle class, on the other hand, they have a lot of, quote unquote, loosely speaking, slack. So the labor supply response is much stronger. So what ends up happening is that the finite amount of labor resources turns to have the same kind of implication as credit frictions or incomplete markets would have, and the lower tail of the income distribution actually worsens. They suffer worse outcomes compared to the upper tail. Now, that sort of gives a hint of what will happen if you add in health production. Because what will happen is, at the lower tail of the income distribution, when you increase inequality exogenously, it is going to necessitate an increased response in the form of labor supply. Labor supply is already high, which means health production is already fairly low. And when you increase labor supply even more, you're closer to the maximum. You are closer to the lowest amount of healthy time that you can invest. So health production is going to suffer a lot more at the lower tail than at the upper tail. So what I have here is, on the left-hand side, simulated life expectancy, the Preston curves. Well, not the Preston curve, because this is across the income distribution, household income distribution. So what you see is that health production suffers systematically as you increase the degree of aspirations that's going on. And the left-hand one is a nonlinear fit. There's a little bit of a nonlinearity, there's a little bit of noise at the lower tail, which is introducing this non-monotonicity. I don't think you should think much about that non-monotonicity. Here's something else that happens. When you add in health production, though, it's no longer clear that aspirational societies have worse inequality outcomes than non-aspirational societies. And what is going on is something that Hall and Jones identified in their paper, which tries to explain the rise of healthcare spending. They argue that in standard life cycle models, when you write down standard sets of preferences, health turns out to be a luxury good. That is, the income elasticity of health spending tends to increase with income. So for moderate levels of inequality, what happens is that the rich are already satiated in terms of consumption level. They do not have a big consumption aspirations shortfall. So they start prioritizing health production. So any increase in income goes towards greater investment in health production, and that tends to reduce consumption inequality or income inequality even more. But then if you talk about more inequality, more than moderate levels of inequality, that effect goes away. Equilibrium inequality always worsens. The other thing what we do here is to ask, well, what is the welfare cost? And so the way we implement that is to say, well, let's think about an aspirational household. How much life years does that household have to be compensated by in order that that household is as well off as he would have been without health production? And that gap, that welfare cost, can be as much as 6 years at the lower tail of the income distribution and drops, but it's still fairly significant 3 years at the upper tail of the income distribution. Very quickly to wrap up, then we kind of try to make sense of the evidence that I talked about. Notice that in the model, the evidence is consistent, the implications are consistent with what Deaton identifies, the effect of relative income distribution, deprivation on health production. But what about the aggregate evidence? So at the aggregate level, something interesting is going on, which is something that is not novel in terms of what we find. It's something that has been identified in other contexts. But in this model, what happens is consumption is an aspirational good, health is not. So any increase in income gets disproportionately allocated towards consumption spending and less towards health production. And what that means is that at the lower tail of the income distribution, where the relative deprivation gap is the highest, Any increase in income or any decrease in income does not change health production as much because people are not responsive to health investment. So when you start doing mean preserving spreads of inequality, you don't observe a big negative impact on life expectancy. So for example, I have this case. So this is looking at simulated relationship between life expectancy and Gini. With aspirations, there's a faint negative relationship. Without aspirations, there's a strong negative relationship. And then we tell lots of different kinds of stories. So for example, we say at the lower end of the income distribution, people are actually constrained in terms of their health investment. So any income gains will actually help. Any improvements in medical innovations will help them more. And so we simulate the model by changing exogenously the wage rate and the productivity of health investment. And what we find is that if you kind of try to calibrate it to average life expectancy that the US has experienced in 2010, this negative effect that you see in the red case disappears. So if you simulate the model and test it, the correlation is very close to zero. Okay, but one thing that is systematically there in the model in terms of the prediction is that inequality always has a consistent effect on health outcome inequality, either in terms of health stock or life expectancy Gini's. One of the things that I hope to pursue down the road is think a little bit harder about this aspirations formation. This is a fairly mechanical model. Everybody is endowed with an aspirations level, and they respond in a very mechanical way to that aspirations level. I think the more interesting question is to understand why some people are aspirational, some people are not. And in this particular case, also trying to understand why some people might be more upward looking in terms of how they form their aspirations, and others might be responding to something much cruder, like the average living standard in society, or how they're doing, the kind of neighborhoods that they're picking in terms of their peer effects. I didn't get to talk about general equilibrium effects. One of the things that we don't do here is to have a feedback effect. If interest rates are decreasing in capital accumulation, standard diminishing returns production function, some of the results will get weakened. But on the other hand, if you followed any of these models that try to match wealth inequality, one of the central lessons that you find from that is that there is, in order for those models to fit the data, you need to endow the rich with a different capital production technology than the poor. So the rich actually do earn higher rates of return on capital, not less just because they have higher capital stock. Okay, stop here.